Okay, so because we still have same graph, same number of partitions, we still do the same thing for the bottom portion of the rectangle. It's just b minus a. And again, this has to be on a closed interval. So, and I divide that by the number of partitions. In this case, it's going to be 2 over 4. So the bottom of each needs to be 0.5. And again, I said this before, I'll say it again, it does not have to be the same length, but for this, it makes our life a lot easier if we make everything, all of the rectangles the same size. So we're going to use, again, 0.5, 1, and 1.5 to draw our rectangles. Now, with the right hand approximation method, we used everything on the right. Left hand, we start from the left side over here. So here, this will be, I'm starting at the bottom, the left hand side, which is why I am using this point here instead of the one I had in the middle. So for my next rectangle, again, it's at 0.5. So now I'm starting on the left-hand side. So this will be my rectangle inside here. Now notice, each of these are under the curve, right? And again, 1.5, but I'm coming from the left-hand side. So all of these are definitely smaller than what we had on the right-hand side. And then the last one, again, coming up from 1.5, or coming from the left side and going over to 2. So these are the rectangles that I'm looking for here. Now, how do I find those points? Well, what is this point? That's going to be f of 0, which is equal to 1. That again, that means that height of this, that height is equal to 1. The next point that I have, this here that I need to find, again, that point here, that's going to give me that y output, which is my height. That's going to be f of 0.5. That's going to be f of 1. And then the last one we are going to be using is f of 1.5. So this is what the area is going to look like. The left-hand approximation method, it's still 0.5. Now I am going from the left side, which means multiplying by this will be my height of my first rectangle, f of 0, plus f of 0.5, plus f of 1, plus f of 1.5. All we're doing each time from there to there, all you're doing is you're adding plus 0.5 to each of those. So that gives me 0.5 times 1 plus 1.25 plus 2 plus 3.25. This is definitely smaller. You can see that by both of the pictures. This does not have nearly as much area in it. This is equal to 3.75. All right, so we're going to do the same thing again. All of our rectangles are going to be 0.5. So I'm going to draw my first rectangle up here. But how high am I going to go? And here I'm going to go in the middle of this. So for this one, I actually want to find out what is happening at f of 0.25, because I'm going halfway in between the top and the bottom. So this one will be my first rectangle. Now for the next one, again, halfway in between 0.5 and 1, that's going to give me plus f of 0.75. So that's why I'm stopping halfway here. This is going to be my rectangle inside here, and I want this area. And then the next one is going to halfway between 1 and 1.5 is 1.25, and that's the rectangle I want for here. And finally, the last one, halfway in between 1.5 and 2 is 1.75. And that's where I'm getting all of that pieces of information. The height, the base for all of these is still the same. The base is still 0.5. I go ahead and just for accuracy's sake, you want to make sure you have 4 decimals here. So the f of 0.25 is going to give you 1.0625 plus f of 0.75 will give me 1.5625. F of 1.25 will give me 2.5625. And finally, the last one, f of 1.75 is 4.0625. Add all of that up and multiply it by 0.5, and you get this particular area is equal to 4.625. Now, out of all of the methods, the middle rectangular approximation for this case probably gives the best idea of what the area underneath the curve is.